Hi class, for these modules, we want to talk about the behavior of the functions and the graphs of the function for the basic functions like linear, quadratic, square root, absolute values. Now, every time we talk about function, we talk about the domain and the range. So make sure you are aware of the domain and the range. If the graph is given for the domain is the x values. So you want to look from left to right for the range because the range is the y values, f of x. So you want to look from bottom and up. Okay, so for this particular problem, you want to write the domain and the range of h. So for the domain, like I mentioned earlier, we want to look from left to right. And you see right here, we start at -2 and it's included. And we stop at 5 excluded. So for the domain, it's going to be bracket -2 and we go to 5 parenthesis. For the range, we look bottom up. So you see at the bottom right here, we have -4. And then up right here, we have +4. And then once again, you have close the bracket for -4. And then for +4, we use parenthesis. All right, for number 2, you see we have a gap. So we're going to have to write the union for the domain because there's a gap in between. So we go, once again, we go from left to right. As you can see, we start at -1 and then we stop at, we start at -4 and then we stop at -1. And then we start again at 2 and we stop at 5. So we have the union. -4, -1. We use bracket because they are included. Same thing for 2, but for 5, we use parenthesis. Now for the range. You see right here, even though we have the gap, but that's just for the domain. Now, if you look bottom up, you see we don't have any gap. So you see right here, we start at -3 and we end at +4. Okay, all right, moving on to number 3, we want to use the graph to determine the behavior of a function between the indicated points. So you see from point A and B, so we go from here to here. You can see that is decreasing. Okay, from B to C is constant. From B to C is constant. From C to D, you go up, so it's increasing. And from D to E, we go down, so it's decreasing. All right, so let's take a look at number 4. We want to determine the interval on which the function is strictly decreasing. So you see right here, from here to here is increasing, from here to here. So this part is decreasing. This part is decreasing. So we have two different intervals. So we want to go from -2 to -1. And then we have from 4 to 6. Now, take a look at number 5. All right, they're asking you for all the local minimum. So don't forget local. You take a look at each interval separately. So we have this one is a local. This one is a local minimum, right? So we have local minimum at -3 and negative 5. Every time they say local minimum values, they talk about the y values. Now, for part B, they're asking you all values at which f has a local minimum. F has a local minimum. So, and they're asking you for those values. So now they ask you for the x values. So if you look at that point, x would be negative 2. At that point, x would be positive 4. So that's negative 2 and positive 4. And don't forget, that's the x values. So don't get confused between local minimum values and values at which f has a local minimum. Okay, so for number 6, they're asking you for the absolute max and the absolute min. So you see right here for the first graph, the graph of G, we have the absolute max is right here. Okay, and once again, they're asking you for absolute max values. So they're asking you for the y values. So that's going to be 3. The absolute min, a lot of people got confused and think this is the absolute min, which is incorrect because you see the arrow right here. The arrow right here indicates that the graph's going to go on and on and on. So we don't have an absolute min here. None. For graph of H, the absolute max would be this point. And you see there's nothing else. There's nothing else. There's nothing else. So the absolute max, once again, is going to be the y value. So it's 3. The absolute min, in this case, we do have it. It's right here. Because you see this point right here is close. So this point is the lowest point. So the absolute min is going to be negative 4. Okay, so is f of 2 negative? Moving on to number 7, f of 2. So you need to locate f of 2. Is f of 2 negative? So what is f of 2? So 2 is right here. F of 2 is right here. So it's not. Okay. And they're asking you for which values of x is f of x equals 0. So f of x equals 0, which is this point and that point, right? So I'm going to just move on to C right here. For which values of x is f of x negative. So negative, what do we have? We have from here, right? These are negative, and these are negative. All right, so let's do B first. For which values of x, f of x equal to 0. So which values of x? So that one. So I have, oh, I'm sorry, it's not an interval. So it's just a value, so it's negative 4 and 4. Now they're asking you for which values of x. F of x is negative. So don't forget they're asking you for x values. So you can see that we have from negative 5 to negative 4. But at negative 4, x is 0. F of x is 0, so you don't want to include negative 4. So I'm going to put parenthesis there. And then once again, we have 4. And then, like I said, at x equals 4, f of x is 0, so you don't want to include it. So you want to put parenthesis there, and we have 5 included.